Hey everyone, this is just a video about how to do the Beanium isotope lab. And you don't need to get any beans of your own, you can just use the data that I'm collecting on this video for your lab. So the first thing you need to do is look at these two samples of beans that I have. So I've got some black beans and some kidney beans here. We're going to pretend that these are atoms, that these are two isotopes of an atom called Beanium. And we want to take the average of this whole group of beans. And what I want you to do on the hypothesis section right here is predict when we take the average mass of all of these beans together, is that average going to be closer to the mass of a black bean or the mass of a kidney bean? So go ahead and pause the video and write your hypothesis in your Google Doc and then answer the pre-lab question. And then once you do that, you can unpause the video and we'll keep going. Okay, so hopefully you've unpaused the video. What we need to do now is just count the beans. So luckily, I have already counted the black beans for us. So there are 82 black beans, so you can record that right there. There's 82. And for the kidney beans, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 kidney beans. And then right here, you need to add those numbers together, so 82 plus 12, to find the total. And then here, you'll divide the number of kidney beans by the total, multiply it by 100. Divide the number of black beans by the total, multiply that by 100, to get the percent abundance. Now, we just need to find the mass of each of the beans. So we want the mass of a kidney bean and we want the mass of a black bean, but to be more accurate, we're not just going to weigh one bean, we're going to actually get the mass of all of the beans together and then divide by the number of beans, because that's going to be a little more accurate. So I'm going to do the kidney beans first. I'm going to move the scale over here, or the balance over here so you can see it. So I'm going to zero it. And it'll take a while to zero. Okay, so I'm going to put all the kidney beans on here. And all together they have a mass of 6.81. So you can record that on the kidney bean mass. And then we'll just get the mass of the black beans. And altogether the black beans have the mass of 16.33. So you can record those numbers right here, and then all you need to do is divide these numbers by the number of kidney beans right here to get the mass of one kidney bean, and by the number of black beans right here to get the mass of one black bean. And then you'll just use these two numbers and these two numbers and this formula here to figure out the average atomic mass of Beanium. And then you'll just answer the questions. So that's a pretty short video, but that's what you need to know.